Morning, Friday. Um, I know there's better things to do on a Friday, but um, I actually was living in Southern Cal and at Mount Sac um, for oh my gosh, over 40 years, and I just literally got a job up in the Bay Area, so it's so different. I can't tell you how much I miss LA. And I miss the food most of all. Um, but I just want to share my experience with you, and which is why I became a teacher and teaching math because I struggled with math most of my life. I couldn't get through middle school, high school, or even college. It just went over my head. And it really wasn't until I started teaching that I finally learned it. And they say the best way to teach is to learn. So keep that in mind because when I don't know how many of you all are planning to teach someday or are teaching already, you know, sometimes while you're teaching, you're learning like, oh, I could say it this way, or this is a great analogy. So there really isn't a ooh ah. It's really all just understanding that we're human beings. And so hopefully you'll get something out of this that helps you or helps you, with your current students or future students. So let me get started here. And please, you can feel free to jump in if you can't hear me or you want me to reiterate something. I want to be very interactive, okay? I do stutter sometimes, so excuse me if you. I have dyslexia, but I also have verbal dyslexia, so you guys know. But my students, like, they get me. They know what I'm saying. Yeah. All right. So let's see if I can make this work here. All right, so in order to master math, you must understand your brain in general. And I wish this was mandatory. Brain development, cognitive development, human development, all through kindergarten through high school, because honestly, we don't know enough about our bodies, you know? So think of that. I don't know, again, I'm just gonna assume you guys are all future teachers. One of the things that I highly recommend in any class you teach, no matter what subject, is integrate some life trivia in there so students can connect to them. So one of the things I really love about brain development is when I taught high school, I taught life skills, and in life skills, I taught brain development, and I explained scientists thought it took about 20 something years. Latest is that it takes about 30 years for your brain to fully develop. All right. And I remember I was in Europe on a trip with my mom. I was very cranky because I had really bad jet lag. But I remember meeting this woman, and I will never forget what she said to me. She's like, "You don't know who you are until you're 30." And I was so offended. I was like 21, like, what are you talking about? I know who I am, But it wasn't until I turned 30 when I actually started understanding math, because that's when I started teaching in my 30s. And everything started making sense to me. Something happens with your brain when it's fully developed. So one of the last things that gets developed in our brain, just so you know, is the frontal lobe. So when I was teaching high school, when students made a mistake or they did something wrong, inappropriate, I'm so sorry, Ms. Lee, it's my frontal lobe, and just teaching that for the first time. If you can imagine standing in front of a classroom with 40 or 50 kids, and you tell them, you got a hole in the front of your brain, everyone's touching their forehead right here, because that's where it is. And that's what math also involves. It involves decision making, right? And unfortunately, that frontal lobe is responsible for making decisions and understanding what the consequences are. And studies have shown if you take an MRI of a brain of a serial killer and an MRI of a brain of a teenager, they're identical. And that's why they call the teenage years the years of insanity, temporary insanity. Have you heard of that in other countries? The teenage years are the years of temporary insanity, because it literally is. They don't understand the consequences of their choices. And I was there. I didn't care. I got in trouble. I did bad things, right? But that's where their brain is. And we're asking a lot of these kids when we're teaching algebra a lot younger now. And I do feel for college students, especially because I can tell you the algebra that students are learning in college is not the same algebra I learned in college myself. It's much harder, much harder. They're teaching at a level which I really don't agree with, and I know this is being recorded, and I don't care. But I disagree. I think standards have to align with people's brain development and when they're ready to learn certain things. So just to give you a little backup for those future teachers, when I started teaching, the state of California, California State Standard said we teach multiplication at third grade. That's when you teach multiplication. Now, students are learning multiplication in kindergarten. Um, I don't know if I could have made it if I had to learn multiplication at kindergarten. So know that there's a lot of factors when it comes to struggles of math in general. It really is these laws that the state puts on us of what to teach at what age or what grade. It also has to do with how our brains and our bodies develop, um, and they're just not matching up, unfortunately. So, with that in mind, keep that in mind. Okay. So, let's see here. We need to understand that the brain is not perfect. It makes mistakes. And that's something that we're going to touch upon later. Mistakes are okay. Mistakes are how we learn, right? For anything. I don't know if anyone's taken any sports classes or dance classes. You mess up at first, but you keep practicing over and over. And I'm going to use that analogy. I'll refer to it again and again. When you're cooking, I don't know how many of you guys like to cook. Maybe use a little too much salt on this one. Next time you know what to do better, right? Our experiences with mistakes makes us improve our practices. I don't think there's anything as, permanent, but we try, it's the spring. If you don't use it, you lose it, right? Okay. We only know what we're taught. So that's very important for teachers. One of the first things I learned when I started teaching is assume nothing. Do not assume when students walk into your classroom, they already had the skills ready for your class. Do not assume they all have the same background, right? So always keep checking for understanding and have an assessment in the beginning of the semester or the school year and go by that, And this goes with anything in life. Sometimes we make bad choices and we don't realize we're offending somebody. It's just because we weren't taught any other way, you know. So know that. So when people tell me, oh, this teacher's bad, or wow, I just say, well, maybe they don't know. They weren't really taught or trained properly how to teach this, or trained how to classroom manage, or trained how to communicate to people with different backgrounds. For example, my focus is on students with disabilities, and you have no idea how I'm just in shock because I've heard of these people existing, but I had to have a conference with a dean and a professor who was laughing in a student's face when the accommodation letter was given to her. She's like, ha ha ha, I'm not giving you this. You know, um, that little moment in time, whether it was a second or two, it really affects us. And that's something that we will talk about later. But when we're put down, something happens in our brain. It just shuts down. We don't want to learn. We don't want to respect that person. It makes us feel bad, like we're not good enough. We can't get it, right? It literally takes one moment in time to change somebody's whole future. And I know it's painful, but we're gonna talk about and share some of our experiences or experiences that you've heard of other people going through. But it does affect how we learn, our experiences, how people treat us. And most of the time it's just we come across people who weren't taught very good manners, who weren't taught very good teaching skills, right? And that is unfortunate. Hopefully we can do something about that in the future with better leaders. And of course, I told you about 30 years, right? And this is very interesting because I actually also taught a little bit of world history when I started teaching in general ed settings. And I learned in the Greek culture, and this was like thousands of years ago, they couldn't vote unless you were like 35. How did they know that a person is not able to make sound decisions until they're in their 30s? Like they knew this way before there was anything like MRIs or CAT scans or anything like that, right? So keep that in mind. I think the 20s are probably the worst adolescent years. I would not want to relive my 20s for all the money in the world. You know, you think you're an adult, but you're not. You do terrible things and you regret and you're embarrassed about. But that's why we teach about the human brain. And I wish somebody taught me when I was younger so I could control myself, you know, control those teenage urges, control the temptation. It's just your brain. But keep that in mind and remind your students what they're going through and you understand what they're going through. It's completely natural, but let's cope with it this way. All right. Now, this is a video I want to show you. I'm probably going to stop it a little bit before it ends here because there's always a certain part. But I really want you to really pay attention about math from a different point of view, from a human point of view. So watch carefully. Why is math important? Because math is about finding patterns and truth.
Eons ago, we gazed at the stars and discovered patterns we call constellations, even coming to believe they might control our destiny. We'd watch the days turn to night and back to day, and seasons as they come and go, and called that pattern time. We see symmetrical patterns in the human body and the tiger's stripes, and build those patterns into what we create, from art to our cities.
Sometimes math can help us discover.
Roger, copy mission.
We live in an age of astonishing advances.
Sending at about 0.75 meters per second.
Engineers can land a car-sized rover on Mars.
Touchdown confirmed.
Physicists probe the essence of all matter, while we communicate wirelessly on a vast worldwide network. But underlying all of these modern wonders is something deep and mysteriously powerful. It's been called the language of the universe, and perhaps it's civilization's greatest achievement. Its name, mathematics. Where does math come from? And why in science does it work so well?
Albert Einstein wondered, how is it possible that mathematics does so well in explaining the universe as we see it?
Is mathematics even human?
There doesn't really seem to be an upper limit to the numerical abilities of animals.
And is it the key to the cosmos?
Our physical world doesn't just have some mathematical properties, but it has only mathematical properties.
Our physical reality is a bit like a digital photograph, according to Max. The photo looks like the pond, but as we move in closer and closer, we can see it is really a field of pixels, each represented by 3 numbers that specify the amount of red, green, and blue. Could it be that mathematics is purely a product of the human brain?
All right, so wanted to talk about that a little bit. He points out something very interesting that I've never really thought of until I actually saw this video, is that math is really truly the only universal language on our planet. No matter what country you go to, no matter what age, everybody understands what 1, 2, 3 really means, right? And believe it or not, and we'll talk about this some more, back before any technology really happened, how did they know, the Sumerians know about the seasons? They figured it out. They counted the days, the moons, right? To figure out there were 4 seasons and knew when the flood was coming. So they could plan for it. Very interesting, right? And this is all math, right? They just figured out there's a pattern. And it's very important, patterns, because I don't think we realize how much we use it in life. We can predict how somebody's going to react because we study their patterns and we don't realize that we're studying patterns. And patterns, yes, that is math. How many times have you seen or had an experience where, like, oh, I better not tell that person that, like my mom, or she's going to get mad. She'll throw a shoe at me like she always does, and da-da-da-da, right? Or do you know people who just end up with the same type of person they like to date, right? They have this pattern. Okay, so think about that, because patterns teach us a lot about life and what to predict and what to be prepared for. Time. Yeah, we actually are watching somehow. Somebody figured out this abstract concept of time. Even before all this technology. Remember those sundials you guys learned about in elementary school? How did they figure that out? They counted the days. They knew what to expect. They saw a pattern. Okay, what about other animals other than humans? How do they know how many acorns they need to store? That's volume, right? How do they know how many to gather to make sure they have enough? It's just so innate and it's so universal how math works. Even birds, when they make these nests, I mean, how did they, that's half a circle, isn't it? That's a sphere. And we teach that in geometry, right? And what about bees? Bees, amazing when they build their hives, and scientists have said they don't know how they do it without a ruler, but every single one of those shapes, I think it's a hexagon, exactly the same length on each side. How do they do that? How do they know how many to make? What about sports? I know some of us like to watch sports. That has a lot of math in it, right? Football, you're taking scores, you're looking at the yard lines. Yeah, we're looking at how he plays, all that stuff. That's statistics right there too. And people who like to exercise, right? You're repeating the same thing over and over. How many times? If you're doing weights, there's a certain position. How do you know how much something has to weigh? That's math. How do you know how many reps are okay for your body? That's math. How do you know how long you should be on the treadmill for? That's math. And we use it without thinking about it every day. If you look around your world and your room, everything that we have in our life has math involved. Whether it's a table you're sitting at right now, somebody had to measure it, right? Kind of exactly the right measurement. Think about it, your phone, your computer. Yeah, there's a lot of math in there. How do we know how much data this phone can hold and what all the parts are? It's pretty amazing how we rely on things that are made with math in our everyday lives, but we still fear it. What about music? I'm sure a lot of us like music. There's a lot of math in there. You got to know the beats, right? And you count. And it has to be even pace. And sometimes it's faster, sometimes it's louder. And that's all math. It's a lot of counting there. And going to the gas station, just knowing, how much each gallon's worth. That doesn't scare us as much as getting into a math class, does it? And you wonder why. Because it's so embedded, nobody's ever pointed out to us, hey, this is all math, right? Cooking, getting the right temperature, getting just the right amount of ingredients. That's math. You have to measure. You have to eyeball what you measure sometimes. You have to make sure you don't overcook, right? That's math, but yet that doesn't scare us that much. What about shopping? I love a good deal, but that involves math and budgeting, right? How much groceries can we afford? And comparing brands and prices. That's math. And I know we all like clothes, but everything we're wearing right now, because I'm pretty sure everybody's wearing clothes right now, somebody had to measure everything that we're wearing with the specific measurements that'll fit our bodies. It's so innate and it's all over, but yet we don't fear our clothes. Now what about all you guys who love to do their hair? Right? How do you know the angles you have to hold your brush? That's math. Or the temperature you need certain things. Or if you're dyeing your hair, you know, how much do you use? How long do you keep it on your hair for? These are all things we have to calculate, and these all involve numbers. And of course, you know, street lights. Believe it or not, yes, they are. There are timers on there. So depending on where you live, you probably have memorized how many seconds you have to get through that intersection before the light turns yellow to red, right? So math is everywhere. I don't think we realize it. It's there right in front of us, literally, as we speak. So what we want to know is, why do we fear it? Okay. So in order to move forward and overcome any fears about math, we need to pinpoint the main reason. And I tell my students this. By college, it's okay. I wouldn't say this to students in like first grade or kindergarten, but math is based on really two principles: adding and subtracting. That's it. If you can do those two, everything else is based on that. You're just doing a different way. So know that, if that helps you feel a little bit better. It's just adding and subtracting, because multiplication is adding, really, just in groups, right? Exponents, all that stuff. Subtracting is related to division. You're just taking numbers away, grouping them. So if you are not scared of adding and subtracting, then you have what it takes to learn, I would say, up to college level math, undergrad. But there are some more difficult things out there that most of us will never get to, like the math you need for astronomy and all that stuff. So what I want to do is break you out in breakout rooms, and I want you to think about just any takeaways or memories, what I've talked about and what you've seen in that video makes you think of. And let's see if, sorry, I'm gonna get out these breakout rooms right now. No, you know what, Keiko, for some reason, oh, okay, there it is. I was gonna ask for help here. And we have how many people present, Keiko? So I can figure out how many people to put in the breakout rooms.
We have a 26, and then you can, the breakout room will tell you how many that you have in each room.
Okay, great. So I'm going to break people out in 5, and I guess we'll take it from there, and we'll check in and see how everybody's doing. How about a good, should we say 15 minutes? Okay, 15 minutes to talk with your. Let me start my timer. Is everybody going? Not everybody's going. What's going on?
I don't think we are getting the invitations yet.
Let me see. Let me try this. I'll put open all rooms.
There you go. Now we do.
Okay, I'm gonna set my timer now then.
Okay. And then you can pause the recording for us, please.
Oh, yes, of course.
Thank
you. So remember in the beginning of the video, math is about patterns, right? And when you keep doing the same problem over and over again, you're gonna notice that the steps never change. It's always the same. So one of the things that I made students write in their notes is, for this type of problem, first do this, then do this, then do this, in their own words. So on every test that I ever gave, I would test them on and make them write in words. How do you solve, a linear equation? How do you solve a quadratic formula, right? And they would have to actually write in words. Well, first you do this, second you do this, third you do this, and then I would give them some problems. So that way the steps are right there and they can look at it. But also I know if they're not following the steps they actually wrote, right? We have a problem. You're not practicing what you're preaching here. You're saying this, but you're doing something else. But when we started using words, they were able to express it in class. And this is where it gets really fun. I think it's really great with little kids because they're so funny. You put them in groups, they're up at the whiteboard. And you see these conversations happening and they're debating, no, it's gotta be this because of this. No, but you see that negative, that means minus and da-da-da. And so it's great when you can use words in math and have a discussion, because when we can hear our own voices and experience that back and forth human connection, it helps our brains remember better. Okay, so it's not just the numbers, it is the words. So Marissa, you are right on. It's totally the words. Okay, but we want to get through, like, what's the scariest thing that could happen? The scariest thing. Like I said, for my student, it was just the trauma of being told she was stupid and being locked in a closet. And that just did it for her. And after she took a couple of my classes, she superseded me. She could explain everything and she was the go-to person. So you're never too old to learn. As long as we're alive, our brains are working. We just got to keep it active, like any muscle. So would anybody in any of the groups like to share out some of their takeaways or stories with the rest of the group?
I actually, like, when I was talking to my group, I mentioned how there's this huge negative, I called it, your math is negatively stigmatized in our society, and especially like television and stuff. I think like whenever you, even kids shows, I don't really remember specific episodes of what specific show, but I've always came across like movies where kids have so much trouble with math. And so you kind of grew up with this mentality that math is so difficult, because math, math is numbers, and in English class and bio classes, there's not a lot of numbers. So it's like when you're introduced to math, you're introduced to this whole new language, and I think people are scared of that. So they grew up thinking that math is impossible, and you need to exert so much effort into it. Like we don't really, like, in our society, they don't really tell us like, oh, math is part of our everyday life. It's something we do on daily basis. It's more of like math is hard and you need a ton of help to actually understand it.
Yeah, I'm glad you brought that up, because actually a lot of math is actually just copying what you didn't touch from the bottom line. So if somebody walks in the room, it looks impressive, but it's really just copying. The higher level you go, the less math there really is. But yes, I think a lot of it has to do, you're right, that we advertise math as something negative, right? There's so many signs out there for tutoring, and it's like, it makes you think, oh, right? Like I think we mentioned, if you're taking math, you must be struggling, kind of thing. Thank you for sharing that.
It's like, oh yeah, of course. Like I think it's also similar to how larger people are portrayed as bad people who are bullies. It all depends on how you present things. That's something I just wanted to put out there.
Exactly. A good teacher makes or breaks.
Like that happens all the time.
Yes. For those of you who may be teaching college, I tell my students, those first 2 weeks you can add and drop and get your money back. I want you to really think about it, because learning has to do with a good relationship with your teacher. And if you know it's not going to work, that the communication's not there, you can't understand that person, or they're not reasonable, I want you to drop that class and get your money back and find another professor to take that class with. Because honestly, 99% of the time, it's the teacher. It really, really is. So thank you for pointing that out. Anyone else? No one else? Not even in the chat box? I just want to make sure before we move on. Okay, alrighty. So if there's nothing else, I'm going to, give me a moment. I have to minimize you guys to share my PowerPoint. Okay. So we already did the breakout right now. We did the share out. Okay. So one of the things people tell me that they're scared of is they're scared of making a mistake. But mistakes are good. And let's watch this first, and then we'll chat about it.
If you graduate from college with straight A's, you have to do some serious soul searching as to why you chose to spend your time doing that.
For most people, you go to school, they tell you what class to go to, what classes to take. This goes all the way through university. They do this, and then you go into the class and they say, you learn this, and this is the information. And it's largely a memory-based, instructional-based process. I hated school. I really hated school. I hated school. Generally, right? Because it was this instruction following thing. Now, I bet you it's probably also because I wasn't good at it. And some people, I've got a great conceptual memory and a terrible rote memory. So if I have a story, I could tell you year by year kind of what happened within a story, within a context. But if I was to go into, like a memory-based learning, it's terrible. I have a terrible rote memory. Ego barrier is the worst thing. And if we were raised differently, just imagine in the schools, all along, the people will always say, everybody makes mistakes. Everybody has weaknesses. The key is really to understand what your mistakes and weaknesses are so that you can learn from them. Right? I think punishment is a terrible concept. Punishment means that you made a mistake and you're being punished. I think instead of punishment, every time somebody makes a mistake, you should say the only thing that you need to do to get out of your punishment is first think, what kind of mistake was that? So if I'm in a situation that's like that again, how would I deal with it differently, not to make that mistake? So that learning should come from the mistake, not punishment, because you're teaching people not to make mistakes. Where's where the learning comes from, not the appreciation that if you keep doing this over and over again, you're going to keep encountering the same outcomes. And education is very. Okay, so I'm going to stop right there.
If you graduate from college.
Sorry. All right. Before I pull up some CBS math questions, actually I should stop share because I need to hook up my iPad for that. Any thoughts on that anybody wants to share out? Your thoughts about how mistakes are good?
Can I say something?
Sure.
I really agree with him because most of the time when working as a TA, I hear that a teacher, like, sometimes he gets mad that they make a small mistake, but I didn't want to try to say like it's okay to make mistakes for certain students because that's how they learn and process like what's happening. And I never did encourage it, but because I felt uncertain about myself, encouraging them and making them feel like it's okay to make mistakes all the time. But I wanted to try and tell them like it's always okay to make certain mistakes as long as you get to learn from what you did wrong and what ways you could correct yourself.
Right. And I don't know if you've ever had teachers who actually let you redo your mistakes on any math work, to get more points. That's one thing you can do for your students. For me as a teacher, I can tell you, I don't care about the answer. I care about the work because the state standards say, and the Common Core standards say, there's nothing that says the student needs to get the answer right. It says they just need to understand the concepts. So if you can prove to me you understand the concepts by explaining it to me in your own words, whether you want to write it down or talk to me, or if you want to, and then if you can prove to me you understand it, honestly, I'll probably give him full credit, or at least 99% credit. But I know teachers who actually mark off if the work is right and the answer is wrong. But again, remember, I said that the human brain makes mistakes. We think we're putting the number and it's something else, and we don't know why we did that. And let me give you a real life analogy about how we make mistakes. How many times has your brain tricked you to think your phone is ringing, right? Yeah, that happens. Or how many times have we been on the road, we think, oh, nobody's at that lane next to us, let's scoot over, and then somebody's honking because they think that we're trying to crash into them or cut them off. And again, I think if we taught brain development, I think there'll be less road rage too, because like sometimes we don't see it. What we see, what we hear, our brain can process it, right? It can process it wrong and give us mixed messages. And we just have to say, hey, sorry, I didn't see you. But some of people, they're just so neat. They don't care. They flip you off on the road. And that's not how we want our kids to grow up, right? We want them to know about what it means to be human. Our brain is not perfect. We make mistakes. And yes, we will always make mistakes. And that's just part of life. We just have to figure out how we're going to fix those mistakes or make them better. So I wanted to do a couple of practice tests from the CBEST because I don't know if you've actually taken a look at some of these, but it is expected that you do take the CBEST. I think that's an entrance exam to teach. I had to take this when I became a substitute teacher, and then eventually I had to take the CSET. I don't know if the CSET's still around, but so let's see. I just got this iPad. Keiko knows. I'm going to do my best. Let's see if we can do like 15 minutes of this. I pulled up a few problems here. So this one is a great one because I think this one definitely relates to real life. This is a table, and we're going to break it up. Let's break down the problem and see what they're asking for. Okay, so sorry, I'm just new with this pencil, is it? So this is very new to me, so bear with me. I apologize if my writing's messy. So I want to read this. On the 3 sections of a math test, a student correctly answered the number of questions shown in the table above. So these are the correct answers right here. What percent, we're looking at percent, of questions on the entire test. So the entire test, this would be the entire right here, right? The total. Did the student answer correctly? So, you guys like grade papers, right? We're gonna put that into a fraction. So whenever we're trying to figure out a percent of a score that a student gets, know that the denominator will always represent the total, right? And the numerator is what we're looking for, or what we're measuring. Right? So I'm gonna see if I can, I'll try to change colors up later. Let me know if the red is bothering anybody. But okay, so we want the total. So we're gonna add up our total numbers here. So I see 0 plus 5 plus 5, that's 10, right? Carry the 1. And let me know if I make a mistake, because I usually give extra credit for students who can catch my mistake, because that tells me 2 things. They are paying attention, and number 2, they understand the concept, which is awesome. So my students are always paying attention because they want that extra credit. They're just waiting for me to make a mistake, which I do often, by the way. So please, just shout out if I make a mistake here. So 2 plus 1, that's 5, and then 1 more is 6. Did I get that right? If I didn't, can somebody please tell me? Okay, so what I'm going to do is I'm going to take this total number, from this column, and I'm going to put it right down here because that's my total right here, right? Now what we want to do is they're asking for the percent the student answered correctly. So that note, we know that's going to go on the top here because that's what we're looking for, right? So let's see how many they got correct. So I'm adding this column here, 7 plus 1 plus 0, that's 8. I don't have to carry over anything. And just so you know, I don't see a chat box. So can you just like unmute yourself and let me know if I'm making a mistake or you have a question? It's okay. Stop me, I'll answer any questions. And then 2 plus 1 plus 1, I think that's 48. Does anybody disagree? You're so quiet. It's okay. Okay, great. So remember, that's the answer is correct, and we are looking for correct on the top, right? On the top, we're looking for correct. So that's where I'm going to put the 48. Now, this is what I call a teachable moment. Before I move on, I just want to make sure everybody understands that fractions are actually division problems. Did you know that? Okay, and if you don't, or if your students don't, please point that out to them. So let me see, I'm going to just play around here with a different color. How do I close this? I'm not sure. Okay, I'm just going to leave it there. All right, so this is, I actually undid things I shouldn't have, didn't I? All right, there we go. Okay, so there are actually 4 different ways you can write division. So let's say I'm just going to make up numbers here and I'm going to put an examples. So know that if I have 48 divided by 60, you read from top to bottom. That keyword is by. Okay, I'm looking for that by. The same thing, it's the same thing, so that's one way to write it. The other way to write it is 48 divided by 60. This is the by right here, right? Another way you can write it is 48 divided by 60. Now, if you get into ratios, you can do 48 to 60. So whenever you see a fraction, I tell my students, know that this means division. So you are actually dividing. Okay. I know people say, oh, it's a fraction, but they don't know what to do with it. But it's really division. So if you have calculators, you can go ahead and divide 48 by 60. You can reduce first as well. Say you can't use, a calculator on the test, which you probably can't on the CBEST. So now reducing means you're dividing the same number on top and bottom. Okay. So you can divide by 4 or 2. No, any even number you can always divide by 2. So if you have to do that a bunch of times, that's okay. Don't let any teacher tell you that's wrong, right? Sometimes a longer way is the easier way, and that's okay. Not everybody likes to do it the fastest way. So for me, I'm just going to pick 4 because I know 4 can go into both of these. So 48 divided by 4, I know 4 goes into 4 once, 4 goes into 8 twice, 4 goes into 6 once, 2 left over. Is that 15?
20.
Yes.
Okay.
Okay.
And then, thank you. Yeah, I need voices or else I'm just listening to myself. What can I reduce both top and bottom by?
3.
3. Remember, reducing means we're just dividing, right? So make sure your students know those key terms. They need to know math vocabulary. It's a little bit different, but it is very literal. It doesn't try to trick you. So 12 divided by 3 is 4. 15 divided by 3 is 5. And we know 4 divided by 5 is what? And if you're not sure, just do it on the side here. I know 5 goes into 48 times. And you don't even have to finish this because what I'm looking for is any of the answers here. Sorry, I was trying to scroll. Do any of them start with the 8? right there, right? So I don't even have to keep going. So when it comes to test taking, make sure you teach your students test taking strategies. They don't necessarily have to finish the whole problem unless they have that type A personality and they really need to have that sense of accomplishment, right? And finish every single problem. But we already know that this is going to be 0. And then you move the decimal over 2 times. That's how I know you get that percent. Okay. And that's your answer. But honestly, you just need that first number. You can narrow it down on your choices here. Any questions on that one? Okay, I'm taking a look at the time. All right, let's keep going. And I may skip a few of these, the easier ones. This one's a little tricky. Do you guys want me to do this one or? Oh, sorry. It looks easy, but it's a little tricky. So let's take a look at this one. So what they're trying to do, and I don't like standardized tests, is they're automatically trying to trick you, right? They want you to look at this number 6 because it's at the very end right here. And so you're looking at the end of the bridge and you're like, oh, that's like 6 inches long. But let's read this really carefully. If the actual length of the bridge is 4,200 feet, right? So they're saying from here to here, this is going to be 4,200 feet. What is the scale of the diagram or the diagram of the bridge? So it looks like we are comparing feet to inches on this ruler here. So what we got to figure out is exactly how many inches is this bridge if it starts right here. So what they're hoping for is that you forget about this part. So I'm just going to put an X so we don't count that, right? Because people are going to count 1, 2, 3, and it's 6. Wrong. What we want to do is actually count from here to here. That's 1. That's 2. That's 3. That's 4. That's 5. So it's not really 6, is it? We're comparing feet to 5 inches, not 6. So be very careful. Break down those diagrams or any illustrations they give you because they will try to trick you in those. Very, very carefully. So how do we know what we're going to do? I know I'm doing a scale, which means there's going to be a fraction involved. So always look at your answer choices. What do you notice about all these answer choices? They're basically whole numbers. I don't see any, like, yeah, there's mixed numbers if you look at this, but I see big numbers in the hundreds, which means when I'm making my fraction, I'm going to put the big number on the top because we know whenever we're dividing, the bigger numbers on the top, we're going to get whole numbers, right? So feet, 5 inches. If you're good at reducing, you can just look at that and know you can reduce 5, both top and bottom. If you can't see it, that's okay, write it out. And again, you're not going to do this whole problem. You just have to get that first number and try to break it down just to save time on a test. So how many times does 5 go into 42?
8.
8. Stop right there. Do we see any numbers that have an 8 in front of it? Right there, right? We can eliminate these because there are no 8s. Now, if you had more than one 8, right, in the beginning of answer, you probably have to keep going. So if you just really want to, just for peace of mind, double check, then keep going and see if you actually get 840. So let's work it out. We've got 40, right, minus, notice I'm just minusing groups here. 5 goes into 20 4 times. Oh, look at that. I got my second number, right? And I know that's 0. Does that check? Yeah. How'd you feel about that one? That one was tricky, right? It looks simple. What they're going to expect you to do is they're hoping that you actually divide by 6 instead of 5 there. So be very, very careful. Really look at your diagram. All right, let me just keep an eye on time here. Oh, we're almost out of time. Do you guys want me to do one more, or do you want to kind of wrap up with another discussion?
Professor Lee, there's a question. Irene's asking about, can you divide a feet by inches?
Oh, it's by scale. Yeah, it's units. Sorry, thank you. Thank you. Somebody's paying attention. Right? Excellent, thank you. Yeah, because sometimes they will trick you with the words. So look at that. Okay. But yes, we do use this in real life. Actually, we used to. I don't know if we do it anymore. But when we had maps, right, there would be a little legend to tell us, hey, this much is equivalent to 1,000 miles or 500 miles, and we'd have to kind of measure it. The other way you can do this is if you have the time, really break this up. We know it's 42, so how can we like make this into 42, right? Each one of these. Sorry, is somebody talking? But yeah, I feel like next time I need to do a 2-hour session with harder problems. I do want to give a chance to wrap up. So let me actually stop share here. And we have what, 12 minutes? I'm sorry, I always try to I always run out of time. That's my weakness. But I do want to share one more thought, and then Keiko's going to wrap it up. Let me see. How do I share my screen again? This is really important, especially for future educators, because I don't know if I'm ever going to see you again. I hope I do. I hope I get to meet you again somewhere. But know that every single person, not only do we all have a brain, but we think differently, we process differently. Our perceptions are going to be completely different. That's why one person may not be offended by a comment that another person is. So I want, again, this is patterns. Math is about patterns, right? And it really teaches us how to make better decisions in life. I want you to look at this and see how you would get from this to here to here. What's the pattern? And don't think in numbers, and you'll hear a voice pop up prompting.
Now, I want you to think without any numbers at all, or without any algebra. I want you to think entirely visually. And I want you to think about, where do you see the extra squares? If there are more squares in case 2 than case 1, where are they?
So take a moment. I gave you extra time. So here's some students and teachers how they saw the object getting bigger and everything.
Oh, I see it like raindrops, where raindrops come down on the top. So it's like an outer layer that grows new each time. It was also my undergrads who said, oh no, I see it more like a bowling alley. You get an extra row, like a row of Skittles that comes in at the bottom. Very different way of seeing the growth. It was a teacher, I remember, who said to me, it was like a volcano. The center goes up and then the lava comes out. It was another teacher who said, oh no, it's like the parting of the Red Sea. The shape separates and there's a duplication with an extra center. And I remember this this one as well. Some people see it as triangles. They see the outside growing as an outside triangle. And then it was a teacher in New Mexico who said to me, oh, it's like Wayne's World. Stairway to heaven, access denied. Done this, so why is that squared, do you think? Why do you see that?
So please know that everybody has a different perception of anything in life, really, right? They have different opinions, they have different backgrounds, different experiences. So based on our experiences, we're gonna process things and try to make sense of things differently. And we have to respect that. as future teachers and current teachers. So any share outs from that? Anyone want to share out about that last clip? No one? Everyone's tired. It's Friday. But I do hope that I know this was very brief, and if you would like me to do more of these with specific types of problems in the future that are more challenging, I'm happy to do that, or even do a CBEST prep course. Happy to do that at no charge, because Keiko knows I love teaching. One thing about teachers, for you teachers in our group, we love sharing our knowledge with as many people as possible. And I'm all about the next generation of educators who are going to take over when I retire. So I just want to share everything that I know with all of you, and hopefully you can make it your own and build on top of that. So please don't hesitate to reach out if you'd like more of these. I'd be happy to do that for you. And if there's specific topics or concepts you want me to concentrate on, I will definitely create that for you. I'm going to hand it over to Keiko if there's nothing else from anybody.
Bettina, I actually have a question. If you're a teacher, will it be a good idea to start your semester, for example, with just talking about your students' fears, have them express their fears, or?
Yeah, you know, I wouldn't put it that way, because then that's really scary. That's showing your vulnerability, right, to people you don't know. But it's nice to have a conversation and maybe do like a fun activity.
Yes.
Like an icebreaker that has to do with math, and then you'll see certain things come out, like what's your favorite thing that you learned in the last grade, right? Or who was your teacher? What would you like to learn more about? And then based on their answers, it'll tell you a lot about what their fears are and what their insecurities are as far as math. But the whole thing is creating a very, very trusting environment where they're not afraid to make a mistake. Because remember that video about mistakes? It's okay. And we shouldn't be put down for it or laughed at. And that's where the trauma comes in, right? I think a lot of that has to do with students being scared to take a math class because they feared that when they were little, maybe in elementary school or middle school, when they were taking a math class. Maybe somebody laughed at them, who knows? But I've kicked out students before for being disrespectful, for being rude to a class member. And you'd be surprised. The rest of the class just started, hey, stop being mean. It was just a mistake, and da-da-da-da, she knows it. And it's nice to have that thing like, it's okay, I made the same mistake. That's how you learn. But really important, please know, math is just like anything else that you learn. You have to keep repeating it. Think of it like a instrument or a dance or some kind of sport. If you get stuck on a problem and then you finally get the steps, I want you to just keep doing it over and over until it becomes automatic, right? The whole thing is trying to become automatic. And people ask me, oh, I don't have enough problems. I'm like, you don't need a bunch of problems, just work on one. Do the same problem over and over until you're comfortable with it. And that's what we do with, performers, right? You just have to keep doing the whole thing over. And maybe it's just one step that you always get stuck on. So just focus on that one little step. Once you get that right, then do the whole thing over and over. But if you can think about it that way, think of it as something that you would train an athlete on, except you're training your brain, right? Thank you for that question. Anything else? Thoughts, comments that you want to share out? I don't see a chat box, so sorry. I don't know if anyone's asking any questions. Keiko, can you look?
Yes. No, I think that everybody's. Oh, there is one student saying that the word problems are addressed for me. That's one of the one of the comments.
Yeah. So word problems. Actually, there's a pattern depending on what kind of word problem is. So if you have a really good teacher, they'll point it out to you. Usually, especially with systems of equations, if you don't know what they are. So the first sentence will always represent one equation. The second sentence will represent another equation. So know that, yes, there are patterns in word problems. So really, I would say know your math terms, your math vocabulary, because it will literally say, solve this equation or solve, this systems. And if you don't know what that means, like what linear means and all that, you're not going to know how to decipher that word problem, because depending on the concept, there's a certain way, and you just have to memorize it and know the pattern, right? So I can look at an equation, I can tell you what it is, if it's a straight line, a circle, a parabola, because I recognize them. Just like you would recognize somebody you know. How do you know that's your mom? How do you know that's your friend? You recognize the lines of their face, the color of their hair. They have a certain look to them, right? They just ingrained in your mind. So when I see equations, I'm like, oh, I know you. You're a linear equation. Oh, I know you. You're a hyperbola. So you kind of get to know them. The more you create a relationship with your math problems, and talk to your math problems. There's nothing wrong with that, right? Talk it out. A lot of us need the auditory, and we need to experience it. So know that for math word problems, there is a pattern and there is a way to decipher them, so you recognize how you need to set it up. It's just having the teacher point out to you what part comes first and what represents what in a word problem. I hope that clarifies. And if maybe we can practice in another session some word problems for certain types of concepts.
Okay, all right. Well, thank you so much. I wish we had more time to work on problems, because, Bettina is great at showing us like a different perspective, different approaches to, math problems, and making it easy and making it less threatening. But thank you so much for this afternoon's workshop. In the chat box, there is a Google form link to exit survey. If you could please take a moment to open it up and then fill it out as you go. Thank you so much. And then if you need an attendance certificate, there's also an email address in the chat box. Please do email us at tpi@mountsac.edu. It's tpi@mountsac.edu. And then please do give us your name, and then I will be sending you a certificate that has your name on it. So thank you so much for being here this afternoon. And I hope that you learned that sometimes math anxiety is not just the academic ability, but it's just as much like a mental block coming from your own personal experiences. So, I hope that that gave you an idea of sort of like revisiting your memory, and then try to work with it, and then hopefully overcome it or minimize the fear. So thank you so much for Dr. Bettina Lee for this afternoon's workshop, and everybody have a great weekend ahead. Thank you so much.
Thank you. I'm going to stop recording. And